The typical formula that we often see relates distance, rate, and time. Sometimes this is called a uniform motion formula. Whatever, it's not really relevant what it's always called, but I guess I might refer to it by uniform motion. What's meant by uniform motion is that, well, uniform means consistent, so you're not speeding up or slowing down. And, well, motion obviously means motion. Alright, so we've given this formula in three different ways. Distance equals rate times time, rate equals distance over time, and time equals distance over rate. Because in the next couple examples, I'm going to be using this formula in a couple of different ways, and, well, we haven't seen how to manipulate formulas yet. Typically, you wouldn't, if you're looking formulas up, you would never see them written in three different ways. This is the same formula, just written in three different ways. You typically just say distance equals rate times time, and then whoever wrote that down would assume you'd be able to manipulate these in such a way as to be able to get these other versions. And yeah, we'll see how to manipulate those, but whatever. I'll just give them to you for now. Alright, so the developers of a high-speed rail project in California have guaranteed that their high-speed rail will cover 400 miles from Los Angeles to San Jose in no more than 2 hours and 40 minutes. What speed in miles per hour must the train average in order to fulfill this guarantee? So we are given a distance and a time, and we're trying to find a rate. We're trying to find the speed. So it looks like this formula right here is the one I'm going to want. I'm going to want rate equals distance over time. This is, or at least this is the way I want this formula arranged. The distance, of course, is 400 miles. And the time, well, 2 hours 40 minutes is a little bit problematic. You could call this, it's a little problematic because I just want this to be in hours. So you could call this 2 and 40/60ths of an hour. That's a little weird. You could reduce that down to 2 2/3, I suppose. Whatever, I'll call it 2 and 40/60ths of an hour. I got the 40/60ths because there's 60 minutes in an hour, and we've gone through 40 of them, so 40 of the 60. This is exactly where mixed numbers shine, or this kind of thing. But of course, if I'm actually trying to plug this into the calculator, or if I'm trying to do this by hand, I'd probably want to convert this. 2 times 60 is 120. Add that to 40 to get 160/60 and do it that way. Since I'm plugging this into the calculator, I think I'm just going to put parentheses and type the number in. So I'm going to go ahead and do 400 divided by, parentheses around the bottom. I'll do 2 plus 40/60. So when we're typing mixed numbers into the calculator, this is generally the easiest way to do it. You're going to do the whole number plus the fractional part. So this is 2 plus 40/60. And we end up with 150. And you can see the units actually work out. We end up with miles divided by hours. This is why I wanted to make sure this is in hours, because generally when we're talking about speeds, we talk about miles per hour. At least in the US we do. So we end up with 150 miles per hour. Now, one thing of note here is that this does need to be an average speed. This does not take into account the speed up time or the slowdown time at either end, or going around curves or anything like that. So you'd probably have to have a top speed of more like 170 or 180 miles an hour.